My friend Blake asked me, why does the Pythagorean theorem work? So here's a quick explainer. So there are many ways to prove the Pythagorean theorem. I'll show you two. For the first way, cut out any right triangle with legs A and B and hypotenuse C, and we are going to draw two squares. For one square, you are going to trace this triangle 4 times to create a square like this. And for the other square, you're going to trace the same triangle 4 times to create a square like this. Notice that the areas of these two squares are the same. They both have an area of a plus b times a plus b, a plus b times a plus b. So since the areas of these two squares are the same, we can set the area of their parts equal to each other. Now let's talk about the area of the parts. For the left square, I see 4 triangles and a square. The area of a triangle is half base times height. In this case, it's half a times b, and there's 4 of them. And in the middle, I see a c by c square. And for the right square, I see 4 triangles and 2 squares. The area of each of these triangles is half a times b, and there's 4 of them. And I see an a by a square and a b by b square. And when we subtract the area of the 4 triangles from both sides, we get a squared plus b squared equals c squared. Visually, this means that the area of these 2 squares added together will add to c squared. Now, believe it or not, we can prove the Pythagorean theorem with just this picture alone. We are going to compare the area of the big square to the area of the parts. The area of the big square is a plus b times a plus b, and the area of the parts is the area of the 4 triangles and the square inside, which we already found in the last proof. And when we distribute, gather like terms, and subtract 2ab on both sides, we get a squared plus b squared equals c squared. So there you have it, 2 proofs of the Pythagorean theorem.